Kinematics example 1. A particle moves in a straight line so that its displacement from O is given by s of t is t squared plus 3t plus 2. We want to find the average velocity for the interval t equals 3 to t equals 7. So we're going to need an expression for velocity. So velocity is going to be ds dt. So that's going to be 2t plus 3. So v of 3 is going to be 2 times 3, 6 plus 3 is 9. I put meters per second, but actually I was given no indication of the units, so we'll just leave it unitless. And v of 7 is 14 plus 3, which is 17. So the average velocity in this period is going to be the change in velocity divided by the time, which in this case is 4 seconds. So that's 8 over 4, which is 2 of whatever units we have. Very often it's meters per second, so I'll use meters per second. The average velocity for the interval t equals 3 to t equals 3 plus h. So we already know that v of 3 is equal to 9. V of 3 plus h would be twice 3 plus h plus 3. So that's going to be 9 plus 2h. So the average velocity is going to be equal to 9 plus 2h, take away 9, divided by the change in time, which is h. So that's going to be 2h divided by h, which is 2 meters per second. Find the limit as h tends to 0 of s of 3 plus h minus s of 3 divided by h and comment on the significance. And remember here that s was t squared plus 3t plus 2. So we have the limit as h tends to 0 of 3 plus h all squared plus 3 lots of 3 plus h plus 2. Take away s of 3, which is going to be 9 plus 9 plus 2, all divided by h. So that's going to be the limit as h tends to 0 of 9 plus 6h plus h squared plus 9 plus 3h plus 2, take away 9, take away 9, take away 2. So those 9s are going to cancel, those 9s are going to cancel, and those 2s are going to cancel, all divided by h. So that's the limit as h tends to 0 of 6h plus h squared plus 3h, all divided by h, which is the limit as h tends to 0 of 9h plus h squared over h, which is the limit as h tends to 0 of 9 plus h. And of course that's going to be equal to 9. Now if we just look at this expression, it looks like a derivative. And it looks like a derivative that's centered at the point where t is equal to 3. And this is the velocity when t was equal to 3. So that is the velocity when t equals 3.